Hello, everybody, and thank you very much for joining my short summary on the usage of COGNEX VisionPro Deep Learning for the identification of COVID-19 images on chest X-rays and CT scans. My name is Jörg Vandenhurst, and I am the Senior AI Expert of the COGNEX Life Science OEM team. I've been with COGNEX for 6 years now, and I'm located in Aachen, Germany. I will start that presentation with a short COGNEX introduction and COGNEX deep learning introduction, then present the COVID-X and COVID-CT results and compare them with other state-of-the-art CNNs and end with a summary and Q&A section. So as most of you probably don't know COGNEX, I'd like to introduce the company. COGNEX actually is the global player in industrial machine vision in the factory automation space. We have been in business for more than 40 years now, and last year we did some 726 million of revenue. This is how COGNEX products usually look like, ranging from image-based industrial handheld barcode scanners to embedded vision systems for 3D vision and 2D vision, up to VisionPro, PC-based VisionPro deep learning, which is what this presentation is about. Unlike other deep learning architectures, COGNEX VisionPro Deep Learning is not an end-to-end learning approach, which kind of has a bit of a black box character. COGNEX VisionPro Deep Learning basically features three different tools, which is the red analyzer segmentation tool, the green classification tool, and the blue location tool. And as suggested in this image, you can chain them together easily, which is not possible for other architectures. And that makes COGNEX deep learning much easier to understand and maintain. And especially requires fewer images and less computer powers than other CNN architectures. With that, I'd like to dive into the COVID-X study. You can download the paper on arXiv under the link below. The COVID-X dataset also is a public dataset from the University of Waterloo. You can download it from the GitHub, Linda Wang GitHub page under the link below. It's basically 1,500 chest X-rays sorted in the three buckets: normal, non-COVID pneumonia, and COVID-19. It's a bit unbalanced because there's only 258 COVID-19 images in the training data set, while there's much more non-COVID and normal images. On the test data set, there's 100 images for each class in that data set. We benchmarked different CNN architectures like from TensorFlow, like VGG19, ResNet50, DenseNet, and Inception, and also, of course, the results for COVIDNet, which is done by the University of Waterloo. And we benchmarked then again against two different COGNEX VisionPro deep learning approaches, one on the entire ROI and another one where we first segmented the lungs and then did the classification just on the segmentation. This is how COGNEX deep learning, the deep learning GUI looks like. You basically have the image in the center, the database with all the results. So that's a trained green tool here. And you have the confusion matrix and the results on the right side. Below that, you can already see a red tool here for segmenting the lungs. So we use this segmentation tool to segment the lungs and then chain the green tool behind it so that the classification is just done on the lungs and masking out all the background to avoid picking up artifacts from the background and make the wrong decision here. Also, COGNEX deep learning features heat maps, which highlight regions in the image which were important for the AI classification. This, of course, provides additional information for the radiologists, for the computer-aided diagnostic decision-making process. And if we look at the results, we can easily see that the two COGNEX deep learning approaches have much higher F-scores than all the other architectures, which we plotted in this plot, like from VGG19 up to COVIDNet, over the three classes: normal in green, non-COVID in orange, and COVID in blue. You can really see that the COGNEX deep learning F-scores are much better over all the three classes, and especially the one where we first segmented the lungs and then did the classification is even better than the end-to-end approach on the entire ROI. So that means that especially in the interesting COVID class, COGNEX performs much better than the other networks tested. We did the same with CT images. That's the COVID CT data set, and you can download the paper from arXiv again under the link below. And also the COVID CT data set is publicly available on GitHub under this link. It's some 100,000 CT scans, again, sorted in the 3 buckets: normal, non-COVID pneumonia, and COVID-19. And this time we have a bit more COVID-19 images in the training set. It's not so unbalanced as for the X-rays. And Waterloo suggests to use 61,000 images for training and 21,000 for validation and 21,000 for testing. We use 2 other test settings where we reduce the training data and increase the test data. Especially setting 3 is taking it to the limit, only using 32% of the training images and 68 of the images for testing. Again, we benchmarked all major architectures: ResNet, DenseNet, Inception. This time also Google's latest classifier, Exception, and of course the 2 CoViD-Net architectures, CTA and CTB. On the COGNEX side, this time we only did the entire ROI approach, not the segmented approach first. Again, the GUI, this time you can just see green tools here on the CT scans, the confusion matrix, and the statistics below it. Also the heat maps, again, to highlight regions in the image which were important for the AI classification. And if you look at the results, you can really see that even for setting 1, COGNEX has above 99 F-score for all 3 classes: normal, pneumonia, and COVID, and thus is better than all the other architectures in the test. But especially when we reduce the training data and increase the test data, COGNEX still stayed in the 99 F-score region, while all the other networks dropped into the high 80s and mid 90s, especially for the 2 important pathologic classes. So the summary, we can say COGNEX VisionPro Deep Learning is very easy to use because, unlike other architectures, this does not require data curation or coding. It's all graphical. You can easily chain tools together like showed in this study. Heat maps also help to understand the AI decisions. Development time reduces dramatically, and the accuracies are still better than all the other state-of-the-art architectures in this study. And you need much fewer training images than other CNNs, and that's why we think that COGNEX VisionPro Deep Learning is ready for the democratization of AI in radiology. And with that, I'd like to thank you very much for your attention. And for further information, you can meet me at the booth or ask questions or send me an email. Thank you very much.